good evening. So, beginning of the week, I wanted to have a live session pertaining to a subject discussion. So, I have planned this Monday live session, even though we restrict our live sessions to Thursday. As I have mentioned previously, we'll try to have more and more live sessions in the coming days, right? So, today we'll focus on one specific aspect pertaining to the subject dental materials, right? The mechanical properties. So, mechanical properties, understanding mechanical properties is often a challenge. And we have a beautiful review in Philips. So, we'll have some questions from this specific topic, but in a different format. As you can see in the title, who am I? So, we'll have some questions in that format, right? We'll have a set of 5 questions. We'll complete this session real quick, right? So that you can carry on with your respective duties. So, a very good evening, all of you. Hi, Falak, Vinita, Akriti, Kiran, Abhishek, Shilpa, Aslesha, Samya, Mubashira, Srish, Sayali, Preetu, Srija, Agriculture, okay, Amir, Pooja, Richa, Sanju. Hi, a very good evening. So, we'll proceed with our first question, right? Hi, Nikita. First question. I absorb elastic energy and deform plastically before fracturing. I am the total area under a plot of tensile stress versus tensile strain. Who am I? Hi Niba, a very good evening. So the first question in who am I format. I absorb elastic energy and deform plastically before fracturing. And the total area under a plot of tensile stress versus tensile strain. Who am I? I'm sorry I haven't placed any comma or apostrophes there. From the next question we'll have them in our comment section. Is it hardness or toughness? Okay, Richa says elasticity. Falak, Vinita, Malavika, you all say it's toughness, including Srish and Srija. So is it toughness or hardness? Wonderful. It's nothing but toughness. So toughness is the ability of a material to absorb energy, elastic energy, and deform plastically before fracturing. And when you plot stress versus strain, tensile stress versus tensile strain, the total area under this plot is nothing but the representation of toughness. In fact, we have discussed stress strain graph in one of the videos in classes. You can refer that for more elaborate information. So toughness is right answer. Wonderful. Now let's have our second question. The second one. On the stiffness of a material, I am calculated as a ratio of elastic stress to elastic strain. Who am I? I'll repeat. Hi Farheen, very good evening. Second question. And the stiffness of a material I am calculated as a ratio of elastic stress to elastic strain. Who am I? Yes, Farheen, Falak, Mubashiro, Abhishek, Malavika, Kia, Srish. Good to see you all answering real quick. Yes, it's nothing but modulus of elasticity or elastic modulus. Also called as, what is the other name for modulus of elasticity or elastic modulus? Yes, modulus of elasticity is the right answer, but what is the other name for modulus of elasticity or elastic modulus. Wonderful. Young's modulus. In fact, Akriti has asked me a question today pertaining to shear modulus, elastic modulus, dynamic modulus, right? So all the information is available in Flips. And you have any further queries, you can drop a mail for further clarification. Wonderful. It's Young's modulus. Now, third question. Yes, Madhusha. Good. So third one. I am the ability of a material to elongate plastically under a tensile stress. I am also represented or reported as percent elongation. Who am I? So I'll repeat. Third question. I am the ability of a material to elongate plastically under a tensile stress. I am also reported or represented in terms of percent elongation. Who am I? If you want me to give a hint, it's the property which direct filling gold is very unique in nature in terms of having this property. Yeah, it's not proportional limit. Yeah, ductility. Fantastic. So ductility is the ability of a material to stretch under tensile forces, also represented as percentile elongation. Percent elongation, not percentile, percent elongation. So it's ductility. Wonderful. So penultimate question. I am a resistance. I resist plastic deformation produced by indentation force. Who am I? Fourth one. I am a resistance. I resist plastic deformation produced by indentation force. Who am I? See, now I can see a variety of answers. Resiliency, hardness, toughness. In fact, we had discussed toughness previously, right? The first question is related to toughness, if I am not wrong. So I am a resistance. I resist plastic deformation produced by indentation force. It's not fracture of material, but resistance to plastic deformation by the indentation force. In fact, we have an elaborate video on this specific property in our E classes. I even posted that on YouTube way back 1 year or 1.5 years ago. Resilience is nothing but ability to absorb and then give the energy back. Resilience will have a different meaning. So the amount of energy that is sustained upon loading and that is released upon unloading. So that's resilience. We say dentine is resilient. That's the reason why we place a cavity, the depth of the cavity within dentin, shock absorption. So that's resilience. Hardness is the right answer. Wonderful. So majority of you have given it as hardness. So hardness is the resistance to plastic deformation produced by indentation force. We have micro hardness tests, macro hardness tests, right? And final question. I am a strain. I exhibit plastic strain at a particular amount of stress. Who am I? I'll repeat. Exactly, Akriti. Hardness is the ability to resist indentation. Good. Fifth question. I am a strain. I exhibit plastic strain at a particular stress. Who am I? Okay, it's yield strength. Wonderful. So it's a plastic strain which happens at a particular stress, yielding, yield strength. Yield strength is right answer. Wonderful, but creep is different, right? One of you have answered as creep. Creep is time dependent plastic deformation, but this plastic strain at a particular stress is called as yield strength. Okay, wonderful. So before we conclude, I have one general question based on general knowledge. I'm sorry. Okay, a sixth one, a final question based on general knowledge. I'm a country in northeast corner of Africa. I'm also called as gift of Nile. Who am I? I'm a country in northeast Africa. I'm also called as gift of Nile. Who am I? Okay, try answering. We'll just have a recap of all that we have discussed so far. Toughness is the ability to absorb energy and deform plastically before fracturing. So that's toughness. It's represented under or as an area under the plot, or it's represented as an area under a graph plotting stress versus strain. Elastic modulus or modulus of elasticity or Young's modulus is nothing but the stiffness or rigidity of a material, which is calculated as a ratio of stress by strain. Whereas ductility is the ability of a material to elongate physically under tensile stress. Hardness is resistance to plastic deformation under some specific load, indentation, force or load. And finally, yield strength, it's a kind of strain which is exhibited by the material at a particular stress, yield strength. So all these properties are very important. It's not memorizing them, but it's trying to understand what exactly this property stands for and trying to correlate that to various dental materials which we use so that it will be easy for us to understand and memorize. Right? So I hope it's clear. I hope you enjoyed today's session and we'll conclude it here. By the way, the last question, the right answer is land of pyramids, gift of Nile, land of mummies. It is Egypt. Well done. So good job everyone. I'm really glad to see so much of active participation, which is considered the key to enhance your preparation. Once you actively participate, you actually put your efforts and something goes with some sense of meaning and purpose. So see you all in another live session. If at all there is another live session, I'll update you in Google as well as WhatsApp groups. Fine? So if you have any further queries, you can always drop a mail at proudtobedentist@gmail.com. Wish you all the best. Love you all. Just keep the momentum going. Go through yesterday's video. Along with that, I have shared even a PDF pertaining to how to maintain motivation, constant motivation. So that's my favorite topic. So do go through it. Also download the PDF. Try to have these positive reinforcements every day. Just repeat them loud enough. Fine? So wish you all the best. Love you all. Take care. Bye. Yeah, you're all welcome.